I mostly work on consultancy, but we make also special works for special trees. So for the last 25 years, I make a lot of mistakes. So I'm really a lot of experience about anchoring and bracing trees, especially by the mistakes. But I'm going to just make a fast view of the standard, highlighting the things that I think can change or can modify a little bit what it's common for the last years. So what I think it's, we fight a lot in the standards to really find the right words to put on the paper, you know. And I think we have to read it carefully because every word is think it, and we discuss a lot for every word. So when we say the cabling and bracing, it's for significantly destabilized trees. It means significantly destabilized trees because sometimes people begins to say, this is a branch, can fail, or just put an anchor there. You think can fail, just put an anchor there. So it means that we say that for anchoring we need to make analysis on the trees and decide it is a really significantly destabilized trees. This is the meaning of the bracing standard, to first find out if this is something that can be damaged, but making this biomechanical analysis in the first. So this is important because if not, we are making things that are not really needed on the trees, putting material, money and effort, and perhaps changing conditions of the trees that we don't want it. So first we have to study the trees and then work proportionality. What it means proportionality? We have to quantify the defect in somehow, no? And then make the right anchor for the right problem or the problem that we decide it's in the tree. No? So we have to look at the tree. We have to look and decide what the defects, the force working there, and then depending of the tension, compression, torsion, depending of the movement we have on the tree, we have to decide which is the right anchor to install it. Also, we have to take a look around the tree and look at the environment, because the environment plays a big role on the forces on the tree, and it's the right way to analyze the tree, not only the tree inside it, also what is around the tree. So, for example, these trees, touching the other ones, and they have a movement, it's a really slender one, but it's protected for the rest of the tree, so you don't need to put any anchor to avoid the movement because the other trees make it, And so it's, I think it's very important to be very sure that the tree needs anchor. And also I am showing these pictures, it's more about biomechanics, but the anchor at the end is a solution for a problem on biomechanics. And this is the shape that the population of trees normally gets when it's affected by the wind. This is the wind touching a mountain, And this is really, when we mix both pictures, we found out that the trees has a special shape that protects itself from the wind. So the first step is evaluate the tree in the biomechanical point of view and decide if it's really needed to put anchor on this position, or it can work in another kind of solutions. Also, we have to make an evaluation of the risk-benefit of the work, because I don't know. Normally, the installation it means money. It means a lot of effort. So we have to make a balance between what is really needed and what is the benefit of the anchoring, and what's the problem if we don't anchor the tree. I have seen a lot of anchors that way, that doesn't makes nothing. It's just to put the freight out of the people, and it's just a rope on the tree, and it's okay, it's perfect, it's anchored, but doesn't make anything. So one of the things that we really sometimes we don't analyze is that the tree has natural process that it's losing branches, and this is a natural process that we have to respect too, especially for all trees. So not always a branch that can fail have to be protected or anchored. For example, this is a well-known series of pictures that Nabil's collects, and it's very clear that the tree is making things that we have to let the tree make. And we don't have to intervene to protect the whole crown on the top to say, no, I'm an arborist, I don't want that any branch fell down, because this is the natural process and we have to understand it and preserve it. Also, this is a pine tree, it's a monumental tree in Spain, and these branches were up, and slowly in 50, 70 years, they put all the branches down until the soil. So these are branches 60 centimeters wide. So this tree is able to really, in 100 years, put the branches on the soil. This is a natural process. And if arrives an arborist in the middle of the process, say, no, you cannot go down. It's impossible. You're a branch, you have to stay up. So sometimes the arborists make decisions because we don't have the process of the trees working, and it's very interesting. This is a nice picture from Ted Green, you know him. These branches have to fall. One of these storms, I don't know. But we don't have to protect because the natural process of the trees lose that branch, and we have to let the tree lose it because he wants it. So I think it's we have to, in the cities it's different than in the countryside, of course, but we have to begin to think that not everything has to be done in anchoring. One of the part of the standard includes that we have, every time we install an anchor system, we have to describe it in a paper, put it and sing with my name. It's me, I installed this in that place, in these conditions, with these materials and that. And it's very important because this avoids a little bit the extra work or bad works. You have to put it on a paper, you have to be always more safety in the analysis of the tree and what you decide to put on the tree at the end. So this is very important that the standard must makes you put all the documentation on every anchor that you install. Okay, a very interesting thing on the standard is that you can use non-certificate materials. That's, I think, is a new thing, so you don't have to buy only materials for trees. You can buy any kind of materials that is made in, have a certification itself, not prepared for trees. But if you use it, you have to, all the characteristics of the material. This is, I think, it changed a little bit until now, that the people think that only can use materials prepared for trees. So you can use any kind of materials that has his own certification, including if it's not prepared for work on trees. If you use it, you have to sometimes test it and analyze the new materials in order to know the information about the mechanics, the limits, and all that you're going to install on the trees. This is a shock absorber for a cable system, and this is the kilos that you need to really get the limit of this shock absorber. Okay, one of the most complicated things on installing cabling is how we can modify the dynamics of the tree. And this is a point that we discussed a lot in when we write the standard, and it's very difficult to really know that point. So I think it's very important to really analyze the trees because we can make a lot of, or create a lot of problems on the trees installing bad anchoring systems. So this is a thing that we have to think about, and it's really not in quarter or 20 minutes to explain how we can analyze it, but we know that there are a system of damping the movements, and we have to respect this. And this introduce a little bit some change in the height of installation of anchoring, because we let in the standard go a little bit down the anchors to increase the movements of the crown and reduce the affection on the damping. Okay, but before we begin with the anchoring, one of the most important ways of resolve problems in mechanics is pruning. So some people doesn't. I think I put the anchoring system. I put the anchoring system without taking care that it can be pruned, and some trees. This line is over this tree. Okay. In some cases, a small pruning modifies a lot the impact of the winds and arrange a lot of things. So pruning is the first step on making solutions on biomechanics. Also, you want to reduce the impact on the base of the trunk, or you have ways. If we reduce 10% of the crown, we have the increase of the safety factor of almost 30%. So sometimes pruning can resolve a lot of problems that we are now using the anchor systems to prevent it. Okay. So dynamic cabling is one of the most used, and it's the standard puts a lot of pages about it. Yeah? But and normally the dynamic is used to prevent something, not to correct. But in some cases you can use also the dynamic to correct. Normally when you when you speak about ropes for climbing, they recognize three kinds of synthetic materials. It's semi-static, static, and dynamic. In the standard, we have only two, static and dynamic. And this is a small difference with the normal climbing ropes. But the dynamic lets the tree move a little bit inside of, in the natural way. That is a good thing of the dynamics. Yeah, but we have to recognize that when we are in the market, there are big differences between the materials that they are already dynamic. So we cannot say, okay, this is dynamic, then we have to say, okay, this is 8% dynamic, this is 10% dynamic, this is 5% dynamic. So we have to know, not only work in the dynamics, you say, understand the materials and try to find out the characteristics of every material and adjust the material for the problem. I cannot say, I like Cobra, I use Cobra for everywhere. I like polyamida or Gefa or, for everywhere. I need to know the characteristics of Gefa, characteristics of Boa, and then use the good material for, depending on the defect that I have on the tree. This is you cannot read it, but it's the elasticity of rubber and the elasticity of polyamida. It's hundreds of times different, so it's not the same. Use a shock absorber of rubber or use a polyamida like okay. This phrase can generate some mistakes because it's true that during the installation we have to use the information that it's on the manufacturer, but not about the height or where. It's just how you have to supply it or make the connection. So it's important that if you buy a material, you follow the instructions of the manufacturer, except where you have to install it, because the manufacturer knows nothing about your tree, your weight, your wind. So you have to follow the instructions for how to make the eyes or the durability inspection and all that. Okay, that is important to use it, but not. You don't have to make the same installation of different trees because every tree needs his own approximation, okay? So this is a comparative that is in the standard about the most used materials used for dynamic, but this is a profile I made by hand, so it's not scientific, but this is the difference between a static system with a shock absorber, and this is the elastic rope. So when you are using different dynamic materials, the properties of the material is different. So it's your work to understand the materials, install it in the tree depending on the kind of defect you can avoid or give a solution. In my case, I use for a short anchor, I use more perhaps static ropes with shock absorber. And for long distance, I use more nylons or polyamida, but it's my choice. It's not always have to be yours. Okay, but we need to think about not only buy a material and install it, begin to say, okay, it's how much elasticity, how much length, the section of the rope, and this helps you on the decisions to install it. Okay, the dynamic is used for braking prevention. This is the most common. But also the French people are pushing a lot to use it to damage prevention. So I don't want to prevent the breaking of the branch. I just want to prevent the damage around it. So it's another way of thinking the dynamics, and this let the tree make everything he wants. And if it breaks, it's subjected by the rope system. This is an extra difficulty because you need to calculate the impact on the rope, not only the wind and the weight, also the impact. So it can be difficult sometimes. Okay, of course the dynamic have to be installed in the dynamic zone of the tree. Until now, all the dynamics was installed 2/3 of the height of the defect. So this was the main point, no? And we introduced on the standard that you have to work in the elastic zone. It means can be a little bit lower, can be another place, if you think that you need a dynamic help on any place of the tree. So look at the red, the dynamic zone, it's the green lines, go almost until the half of the tree. Yeah? So you have dynamics lower than 2/3, and you can install dynamic ropes lower than 2/3. I'm not saying that you have to. You say you can. Okay, so this is one of the points that adjusting the height of the installation and modifying the slack, you can modify the characteristics of the system, making more dynamic or more semi-static. And this is interesting because the tree has a big variability, and we cannot go with the same solution for every kind of defect. So we can say, listen, I'm going to go a little bit down in this system, and in this tree, with this system, I'm going to go it a little bit up. Okay. This is an example of a dynamic installed very, very low. This is the beginning of the crown, and this anchor, it's painted because to make it easy to see it, installed only 1/3 of the defect. Okay, that's the reason was it the branches are too much thin to really put install anchor there, but installed 1/3 of the high, and it works. It's difficult to have a standard of something that is very sometimes intuitive. You know, why you put there, what more, a lot of solutions, but and this is another dynamic rope installed on the base of the codominant stem. Yeah, so we put it very in tension because we're gonna some movement there until a limit. So now the standard lets you put dynamics not on the place that we put it until now. We can modify if you understand that the point can work good. Okay, the standard recommends a size of the ropes that you are using, or the capacity of the ropes that you are using for the different dimension of the limbs or the branches. No, this is very important because you cannot put, for example, if you use Cobra, you can put an extra force on the rope because the absorber is the rubber. So if you put 8 tons rope in a small branch, it works the same that it's a small rope because the shock absorber is the rubber, you know. But if you put a polyamide of 8 tons in a small branch, it works like a static because there are no force enough to make the elasticity. So it's depending on the material you are using, you have to be careful to not put extra material on the branches because it doesn't work like you expect to work. Okay, this is a small drawing that explains that how the position of the branch can make you increase the capacity of the ropes. And I think the most important is that recognize that depending on the branch orientation, you have the perfect point to subject that branch. It's perpendicular to the weight and wind. And depending on that direction, you have an angle when you can use the estimated wave force. But if you are, for example, if you install a perpendicular to the trunk anchor, you need to double because your angle of working is more than normally 30%. This is more or less the proportion. We didn't put the proportions because we don't want to make a law about anchor, but about 30 degrees, it changed the force that you needed, and again 60 degrees, and after 80 you get infinite needed. So be careful when we install the forces because it's very important that you need to increase the capacity of the ropes that you are using, cables, anything. Okay. Static cabling. Normally we use it materials with a low elasticity, below 2%, and normally are installed down on the ground. This is quite important because the static makes a lot of impact on the movement. So we need to go in the very static. But we have to recognize that the tree is never static at all. So if we put the static a little bit up, it can make changes on the tree. So the static zone is something difficult to define, except if you are with a windy day and you can see the tree where it stops movement clearly. Okay, we need the same consideration to double the capacity of the depending of the orientation, and also in some cases we can use shock absorbers on static materials if we think that there can be some impact on the cable, so we can reduce the impact on the branches to use these static materials on the tree. This is a static anchor, but with a shock absorber. Yeah, it's a mix between static and dynamic. Okay, because there was a lot of movement here, we want to stop it, but with not in a static perfect way. We need to let the tree suffer movement, so we mixed both things. This is not on the standard, but the standard lets you think and understand the trees and use the right solution that you think is important. Okay, all the props are static also because it blocks the movements, so we recommend in the standard to use dynamics like a system to let the tree adapt to the new situation. Normally, when you install a static, especially if you understand the tree can change a little enough the conditions of the movements of the dynamics, it's very important to install adapting system dynamic on the top to reduce the movements and don't force too much the new static zones. So every time you install a static, we recommend to put a dynamic system that can be only for 2 years, 1 year, in order to adapt the tree to the new situation. Yeah, another thing that the standard results is that you can drill a tree. Still, it's one of the things that you can do it when you design an anchor, but you have to take care about, especially the decay of the zone that you are drilling. So we don't recommend especially do that or not do that. It is the worker have to decide where and when to install it, but the standard only says that be aware about the decay or the decay you can produce in order to have a nice evolution of the system. Yeah, propping perhaps is the most strange way of subjecting trees. There are easy props, no? But there are also difficult. And normally when you work on that kind of installation, you need to the help of people that know enough about the soil, compaction, everything that is needed to really install a prop, because a prop is forever. A cable you can modify in 8 years, you can change, put another one. When you install a prop like that, it's for 50 years, 70 years, and so you have to make it in another way, and normally you need the people that helps you on that installation. There are props more easy to install, more easy to analyze, trees more easy, but always you need the help of people. Mostly because you have to redact a document with all the information that the weight that you consider it, the wind you consider it, the force you consider it, the size of the iron bar. You have to put it on the paper because you are making a work, specialized artistic work, and you have to put all the papers to your customer and say they made that. So you need to make a calculation. If you are not prepared to do it, you need to contract a guy that can make it. So this is a specialty that we make a special prop. It's a very famous tree. It was. Now it's dead. But it's a work that we need the help to really, to design all the calculations. So we are not able, like arborists, to make all this prop alone. So we need a lot of help. And I think when you install this kind of props, we have to do it properly. Okay. So this is very important. We have to, you must describe the characteristics of the tree, of the material, the force considerations, and give it to your customer and say you have to be here, come back in 2 years to make an inspection, or you have to inspect it yourself every 1 year, and you have to be all this. And these have to be, it's better uploaded to an informatic system, to have all the information. If not, it's impossible to have a management of, 100 or 1,000 of anchoring that you are installing, your colleagues are installing in a city, for example. Well, we have to force ourselves to have safety certifications. If not, everything is possible. You can go to tree, go back, and it doesn't. But if you force yourself to write down all the information that is needed to anchor, you will change your work because you begin to think, make some calculations. Okay, after the installation, there are some basic inspection. I think Valentino is going to speak about more about that. And normally, the slack and if the tree is eating or not the cable, and this is a system to know if the tree is using a shock absorber. Just, this is special for kids to play. I don't know what's the name in English. Plastiline, we say it. Okay, plastiline. It's a system to detect if the tree is using or not using the cable. But you have to make inspection, basic ones, and then you have to make a detailed inspection every certain years to be sure that the anchor is working. This information have to be in the installer and also in the customer, because they need to know when to visit and etc. Okay, finalizing. One of the most complicated things of the installing the anchor is modifying the whole anchor. And this is example how I make it 15 years ago. It's a monumental tree that I modify the anchor system. It breaks 1 week later. So the replacement is a thing very important to take care of how to do it to don't damage the tree on that operation. Okay, thank you very much.